So we're going to finally put everything together here for 5.6. And it's really just everything that we've done, and now you'll be finding all zeros. Okay, so you could have imaginary zeros, you could have zeros with radicals, lots of different scenarios. But yesterday you guys learned about the conjugate root, or the conjugate zeros theorem, right? So for this problem, we know one root is given to us, negative 5i. So automatically, what's another root? Positive 5i. Good. Okay. And then now, well, it is the easiest part, but it's a very important part. Like if you don't get that, you have no chance, right? Okay. Once you have those two, okay, if this is a degree 3, then there's one more root that we have to find, right? And so now here's how we can do it. Synthetic division. Instead of putting like negative 5 and 5 in the box, you would just include the I when you divide. So no different than what we've been doing. And then you write down the coefficients. So 1, 3, 25, 75. First step, you bring down the 1. Multiply, you get 5i. When you add, you can't combine those because you have a 3, which is real, and then a 5i, which is imaginary. So you just keep them like this, 3 plus 5i. And now you're going to multiply that with 5i. So what's 3 times 5i? 15i. What's 5i times 5i? 25i squared, or negative 25, because I squared is negative 1. Okay? And now we add. 25 and negative 25 cancel, so now we just get 15i when we add that up. Multiply, we get negative 75. Because 15 times 5 is 75, that's 75i squared, really. Does that make sense? I squared is negative 1, so it's negative 75. And, I mean, this needs to happen right here, right? Now we use the other root. So I used R2 for some reason. I used that one first. Now I'm using the first one. We're going to keep dividing, but now we're going to use these new coefficients. Let me just rewrite them. Bring down the 1. Multiply. You get negative 5i. If you add, the 5i and the negative 5i cancel out, so it's just 3. And now 3 times negative 5i, negative 15i, those cancel out. And so what's left here? X plus 3 equals 0. So negative 3 is the remaining 0 that we didn't know about. Okay? So our solutions are plus or minus 5i, and then also negative 3. Yes?
The R1 and R2, where do you get the negative 5 and the 5i?
The negative 5i was given to us.
Yeah.
And then automatically that means positive 5i is a root from the conjugate root theorem.
So when we're doing things like this, we're always going to have 2 answers, and it's going to be the last thing and then the opposite of it?
Well, it'll be the conjugate. So remember the notes from yesterday.
Yes, I don't know how exactly.
It's just switching the imaginaries to opposite. That's it. So like here, if 2 minus i is a 0, 2 plus I is a 0. Yeah.
Like, you know how you had R4?
Yeah.
You got the 4 from which 4? The degree 4 or the one before the zeros?
Because I already have 3 of them. 1, 2, 3, so this would be the 4th one.
Oh.
Like this would be R1, that would be R2, and this is R3, and then the other root, R4, has to be the conjugate of this complex one.
So then that's why for the other one you got R5.
And R6, yeah.
Well, why did you, like for B, you know how you got R5, why did you get the negative I?
Because if I is a root, automatically negative I is a root.
I know, but why did you pick that one? Why did you
I
pick
picked
the other
both of them.
one? Well, what about the negative 5 and 9?
because those aren't imaginary. Those aren't complex.
So
Remember the notes? The conjugate pairs theorem is
the
only for complex numbers. So it's not going to be like a 5 and a -5 or a 6
only
and,
gonna be ones
with
R.
i's in it. Yeah.
What? And then the R6 you got because you already had 5.
Because, yeah, exactly.
And then that R6 to that thing.
Yes.
Negative 8. What?
Okay. Let's go ahead and try example 2a here. Okay. So here we're finding all the zeros. So we're going to start from the beginning. I don't know where my calculator went. Maybe one of you borrowed it. Who knows? Okay. Let's do the P's and Q's. Okay, so this is putting it all together now. Sometimes, you guys, you will be given one of the zeros, and that's the easier problem because you can just plug that in, divide, and then keep going. When you don't have anything, you're going to start with your P's and Q's. So this is what I would need to see. The P's come from the very last number in the polynomial. What are all the factors there? That's it. And then what about for Q? Same thing. Okay, so you could test all, just test, or if you have your calculator, just graph it and see where the zeros are. So take a quick second if you don't want to test it. Graph x to the 4 minus 1. If you're not sure what it looks like. And what are the zeros? -1 and +1?
Yeah.
Okay. Oh, and I forgot to write that. So basically, both our possibilities are actual zeros here. Does that make sense?
Yeah.
What's your graph look like? Something like this? 1 is a 0, -1 is a 0. So now we're going to use that to reduce this equation from degree 4. And now we'll reduce it to degree 3, just dividing by that 1, by x minus 1. What are all the coefficients here? 1, 0 for x cubed. Yep. And there we go. X to the 4, 3, 2, 1, and then none, so -1. Bring down the 1. Multiply. Add. Multiply, add. Multiply, add. Multiply, add. You get 0 for your very last number, the remainder, right? And now we use the fact that -1 is a 0. Same thing there. Bring down the 1, multiply. Add it up, you get 0. Now this will be 0, this will be +1, multiply, you get -1, add that up, you get 0 there. So how does this help us? What does this represent down here? X squared plus 1. And now we set that equal to 0. And we solve this, however, I mean, it's pretty easy to just get x alone here, right? Subtract 1. And then square root both sides. So what's x going to be? Plus or minus I, right. Whenever we have a negative, we're going to get, imaginary answers there. So we have those two, and I forgot to write these down. Obviously, the first two that we found were plus or minus 1. So here are the 4 roots for that problem, or the 4 zeros. Okay. Oh, I didn't read the directions. Hopefully you read the directions when you're doing these. Write it in factored form. So now using all these roots, the leading coefficient is a 1, so we don't need to worry about it. If I have plus and minus I, that means x minus and x plus I are factors. Also, if I have plus and minus 1, that means x minus and x plus 1 are factors. So here is the factored form, and here are the zeros. Okay? Does that make sense to you guys? Yes.
Put it in order from like lowest to highest.
For the factors?
Yeah.
No, it doesn't matter.
Oh, because
Yeah.
when I can sell like It made it all wrong just because it didn't put in order.
We'll look at that. I'm not sure that that's why that was wrong.
Yeah, and then I had 12 parts of it.
There's not 12 parts. Maybe 3. Okay. Let's look at B. We'll do that one together, and then I'll let you guys do the last one here. Actually, maybe we'll just do them both together, just so I have the notes online. What are the factors of 85? Too many. It's actually not that many.
1, 5, 17, and 85.
1, 5, 17, and 85. That is correct. What are the Q values? Just 1. So that means your possible zeros, when you divide every possibility, will remain 1, 5, 7, and 1, 5, 17, and 85.
Is there a fast way on the calculator to find the factors?
No, you just have to, yeah. Like for 85, finding out, you just have to know. I mean, obviously 1 and 85 is where you would start. And because this ends in a 5, I would assume 5 goes in there. So then you can divide 85 by 5 to get 17. Nothing else is going to work.
Okay, I'm just waiting for the task to give a factor somewhere.
Let me show, this is kind of some advanced stuff, but this might help you. Here's what you can do to at least narrow down your search, okay? If you type in the number and take the square root, okay? See that we have 9 point something? Okay? That means that really all you would have to check is numbers from 1 through 9.
Where did you get the 1 through 9?
From this 9 here. That's like the highest number that you'd have to test for divisibility.
So you always start with the number 1. And then
Yes.
And then that
Right.
number. And that's
Right. So like in the process of doing that, so if you obviously 1 works because 1 times 85,
Right.
you would test 2 or hopefully just know it's not an even number, so 2 doesn't work.
Right.
3 doesn't work. 4 doesn't work. If you test 5, 5 works, and now you can figure out that 17 is its counterpart.
Right.
And then if you test 6 or 7 or 8 or 9, none of those work,
And then
you're done. You don't have to worry about like what about 11 or what about. And what I should say is that if you want to be even more specific, this is saying the prime factors. So like for testing, like if you know your prime numbers, you got 2, 3, 5, 7, right? Really what you would do is 2 doesn't work, 3 doesn't work, 5 works. What does it give us? Well, 5 and 17, right? There's no more primes after 7, so you would even stop at 7.
I think I'll just use the square root.
Okay,
And use the 9 as the highest. And so on and on.
that's fine. Yeah, that'll work. Okay, sure. Did you guys graph this yet? Were there any
There's 1, yeah.
1?
No, I mean, like, there was only 1.
1, 0,
Yeah.
and negative 5?
Negative 5.
Okay. So negative 5. Write down the coefficients. Bring down the 1. Multiply. I'm probably catching up to most of you at this point. 8. Negative 40. 17. That's going to be negative 85. And that's a 0, which obviously that should happen. What does this translate to now?
X squared plus 8x plus 17.
Good. We set that equal to 0. And our goal is maybe we can factor it. You're going to figure out real quick that you cannot factor it. Okay? So next, if you can't factor, you got to use the quadratic formula, right? So let's go through that. That would be x equals negative 8 plus or minus the square root of b squared would be 64 minus 4 times a, which is 1 times c, which is 17, all over 2 times a, which is 1, Did anybody simplify the radical yet? What's 64 minus 4 times 1 times 17?
-4.
So that's 68. 64 minus 68 is negative 4. Okay, thank you. What is the square root of negative 4?
2i.
Yep. And since both of these are divisible by 2, we can divide 8 by 2 to get negative 4 plus or minus, and then the 2's divided cancel out. So negative 4 plus or minus I would be the other two zeros, the other two roots. Does that make sense, you guys? Okay. So here are the zeros, and let me just list the first one that we got from the P's and Q's. Factors. Well, again, the leading coefficient is 1, so we can just write out the factors. That would be x minus, and always use parentheses with these weird two-termed roots, negative 4 plus I. And then we have x minus, what would the second one be? Negative 4 minus I. And then, what's the last one? X plus 5. Now look. Yeah.
How did you get the factors from the negative 4 plus?
Well, it's the same way, like, if r is a root, it's the linear factors theorem. If r is a root, then x minus that value, right?
I get that.
That's all we're doing.
So,
Like, this is literally one of the roots right here, and this is the second one right there. I'm just putting parentheses around it. That's it. Like here, we never really would say x minus negative 5, but that's really what it is. X minus negative 5. Distribute? Yeah, you can distribute it, yeah. So then the other option is this. If you distribute the negative, it's x plus 4 minus I. And then this would be x plus 4 plus I. And then x plus 5.
You know how in your example, you used R, so you made the opposite with the x minus R? Would you make with the imaginary one?
Yeah.
Would you make the negative 4 opposite?
No, it's you literally just copy down the root.
Okay.
So I mean, we're making the whole thing opposite by putting a negative in front of the whole thing.
Okay.
Does that kind of clarify it?
Okay.
Yeah.
Okay.
Okay. So real quick, you guys, on an exam, as soon as I said that, everybody got quiet. On an exam, if you leave your answer like this, I'm cool with that. Okay? If you distribute, fine. Just make sure that you don't make a mistake distributing, right? I don't know, honestly, I don't know if Math Excel accepts it in this format or if they want everything distributed out. But like I'm saying, I'm the one grading your tests. If you leave it without distributing that negative, that's fine. Okay? Less is more sometimes. Either one of these is totally fine, yes. Okay? Okay, last one. P's and Q's. Plus or minus, let's see, 1. What else goes into 36? 2, 3. There's a whole bunch. Yep. Q's, plus or minus 1. So all your possible roots are just the original p values, right? Because you're not going to divide and get any fractions out of that. So on the calculator, now we would go ahead and say, all right, what zeros are there? Anybody getting any? Even if you zoom out, right? If you look at the table,
Oh my god.
does it look like it ever hits 0?
No.
I mean, it gets as low as about 36, and then it just comes right back up.
Yeah.
Okay? So, here's the good news. Not quite. There are no real zeros here. So that means that these P's and Q's and doing synthetic division, we can't do this with this problem. Okay? Which then also means, for you guys anyway, that this is going to factor very nicely. Okay? Even though it's to the 4th. Okay? Think about normal quadratics. Like, what if this were x squared plus 13x plus 36? How would you factor if it was just a normal quadratic like this? I know I kind of messed up the writing there. That's a 13. 9 and 4 would multiply to 36 and also add up to 13, right? We're going to try that here. But because it's x to the 4, we're going to make it x squared instead of x. Plus 4, and then x squared plus 9. Okay? Factors very similarly. And if you're not sure or if you're not convinced that this is correct, multiply it out. Multiply it all out, and you're going to see that you're going to get 4x squared and then 9x squared, which add up to the 13x squared. And everything checks out. You guys understand that? Okay? And so now, you solve this like normal. If you set it equal to 0, you get x squared equals negative 4. So x would be plus or minus 2i. And then from this one, x squared would equal negative 9. So x will be plus or minus 3i. So here are your zeros. And I kind of wrote during my explanation for problem 2. Let's just go down here. The factors then would be x minus 2i, x plus 2i, and then x minus 3i, and then x plus 3i. Here are your zeros. Here are your factors, okay? Does that make sense, you guys? Okay, so you have some time